Hello, pre-calc honor students. This is Ms. Orloff, and I'm here to work on the second part of 2.4. Our lesson ended with finding possible zeros, taking those possible zeros and determining if they are actual rational zeros. And it was only to find rational zeros. And just a refresher, what we learned in the prior lesson is that if we take the factors of the constant term, and it must be the constant term, and divide it by the factors of the leading coefficient, that gives us a list of possible zeros. Then we check them by doing synthetic division, and if our remainder is 0, then we're good. We have a 0. And so the one thing I noticed that I almost missed going through this, because, you know, I rush through things sometimes, is this is not in standard form. So I need to think about this in proper standard form. So I did pause the video to rewrite that in a nice, neat format. So I almost missed it. Look at these middle terms. They're not in descending order by the power. And so I really want to make sure I have that before I get started. But let's go back to the possible zeros. So I take the factors of 4, which in our prior lesson we called that p, and that's plus or minus 1, plus or minus 2, plus or minus 4. And we're going to divide it by the factors of q, which are just plus or minus 1. So our possible zeros are simply this. These are only our potentials, so we've got to confirm them. You know, I think a lot of people will start with a starting point of 1. And so I am going to go ahead and I got to set up my synthetic division. Now I want to make sure I don't have any gaps where I need to put that placeholder. If you know me, I like that dotted line, so my remainder sits there. And I'm going to quickly run through by synthetic division. And look, not a 0. So that means 1 is not a 0. So we got to check something else out. Well, let's check -1. So we're starting all over now. So I'm going to reset that up. And then I'd like for you to pause the video and see if -1 is a 0. So I have found that -1 is a 0 because my remainder is a 0. But what we need to remember is that if we started with a 4th degree polynomial, if I put this in polynomial form, this would be a 3rd degree polynomial. Well, I really need it to be a quadratic because I can either factor a quadratic or use the quadratic formula to find the other ones. So I'm going to have to do synthetic division again. And all of my possible zeros are still fair game except for 1 because it didn't work. That means -1 could also be a 0 again. Don't forget multiplicity can happen. I'm not going to check -1. I'm going to check a few other numbers potentially here. What I'd like for you to do is pause the video and see if you can figure out the other 0. So I have found another 0 of 2. Now, I don't have some magic power. It's really just checking all possible zeros if I don't have a graphing calculator. So now I'm at a 2nd degree, a quadratic. I'm happy. So now I know that this can be rewritten as x squared. That would be 0x minus 2 equals 0. So x squared plus 0x plus, so you could see that in there. So this can be solved. X squared equals 2. And recall that any time I use a square root to solve a quadratic, I'm going to think about plus or minus the square root of 2. Unless it's in the context of the real world and maybe 1 doesn't make sense. But there you go. I have 2 rational zeros of x equals 1, x equals -1. Those are my rational zeros. And then I have two irrational, root 2, and negative root 2. Now, the neat thing is that means I have 4 x-intercepts because they're all real numbers, each 0. Okay. Now, I'm going to move on to B. So what I'd like for you to do is figure out your potential zeros. I'm being very kind with, not giving you huge lists of potential zeros. So you're correct. I'm going to have the same list of potential zeros as I did in the one prior. And so my possible zeros factors of 4 over the factors of 1. So I have plus or minus 1, plus or minus 2, and plus or minus 4. So I would never do this on a test, but I want to give you a little hint since this is new for everybody. We always have to consider multiplicity, and this one may or may not have that situation. So I'd like you to go ahead and try to find a 0. So you can see I found my first 0 to be -1. I confirmed that doing synthetic division and having that remainder of 0. Okay, so now what? We could keep checking, but would it hurt to quickly check -1 again in case there is that multiplicity effect? And so again, that's something we're going to want to do. Eventually you might have a graph to confirm that, and you should remember that from the lesson from 2.3. So let's go ahead. I'm going to continue. I like to just continue here because I went from a degree of 4. This is a 3rd degree currently. And our goal is to get it to the polynomial reduced down to a quadratic where I can do more with that. So I'm essentially going to check -1 again. And so I'm going to bring down my 1, multiply it, this is actually where my remainder would go. And look, yay. So I did have a multiplicity there. -1 is a 0 with a multiplicity of 2. And now I'm down to a 2nd degree. And that's really awesome because I don't have to do any more division, right? So I can just jump right in and say, okay, great. I have x squared minus 4x plus 4 equals 0. And I can factor that. And so 2 has a multiplicity of 2. So my zeros, right? I have x equals -1 with a multiplicity of 2, and x equals 2 with a multiplicity of 2, which means that graph touches the x-axis and bounces right off. Okay, so let's move on. And I just want to list the potential rational zeros. This is what I'm trying to do right now. That's all I'm trying to do. I'm not going to actually figure out which ones are. So I want to remind you, the first thing you need to make sure is that this is a constant and we're in the standard form. And this is my leading coefficient. So I'm going to make the p, which are factors of 20, is what I'm thinking about. I know 1 goes into 20 evenly, so does -1, right? If we have -1 times -20, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Q comes from factors of 2, plus or minus 1, plus or minus 2. So my potential, my possible zeros, I need to list them individually. So 1 over 1 is 1, 1 over 2, so plus or minus 1/2. Then I have 2 over 1, so plus or minus 2. But then 2 over 2 is just plus or minus 1. I'm not going to write that again. And so now I'm at the 4. And so 4 over 1 plus or minus 4. 4 over 2. I'm not going to list the 2 again. That's a waste of my time. Now 5 over 1, so plus or minus 5. 5 over 2, there's a new 0, plus or minus 5 halves. 10 over 1 is plus or minus 10. 10 over 2 is 5, so plus or minus 5 is a repeat. 20 over 1, so plus or minus 20 is new. And 20 over 2 is 10, so that's just a repeat. These are my possible zeros. They're not all zeros, they're just the possible. So we're going to factor f of x. This is the same f of x from the one that I asked you to find the linear factor, the possible zeros, into 4 linear factors. Linear. The degree of 1 is on x, okay? You must give me an exact number, meaning no decimal approximation. So the square root of 2 is an exact value. Its decimal approximation of 1.414 is not. The calculator is okay. So I want to refresh your memory. If it's a real 0, it will be an x-intercept. So what you should do is pause this video, graph f of x in your calculator, and find the x-intercepts that are rational. Go ahead and do that now. So I already have the function in my graphing calculator. Just something that might help. If I'm looking for a 0, I don't need really big y values. So like, I don't know, I can even make it -1 to 1, but I'll do -2 to 2. And I could see all of these zeros. I could see, I want a better view, so I'm going to go, I don't know, let's go -4 to 4. Let's just get a prettier picture. And I had found my zeros, and I'm just going to confirm it with you. I don't have a big enough window. I just realized that. So I'm going to go ahead and make this -5 to 5. I am going to confirm that one of my rational zeros with you, I found it already, is 4. You could see 4, 0. And another one that I found that was rational, the other two are irrational, is -0.5, and I'm going to just confirm that with you. And so those are the values that I will use right here. So I'm going to start my synthetic division with 4. I'm going to confirm that I don't need a placeholder. And now I'm going to have you pause the video because I'm not going to walk through any more synthetic division with you. So go ahead and do this. Okay, so I did get that 4. It confirmed it. All right, now I'd like you to do the synthetic division. Continue from here and go ahead and use -1/2 and follow through with your synthetic division. Pause the video. So that's confirmed. So I'm going to take a moment here. We know we have these as zeros. Okay. Now, I'm going to go ahead and say, well, that's the same as x squared. So I reduce this down here to 1. And I'm going to reduce this down to 5. Minus 5 equals 0. So I get x equals plus or minus root 5. So here are my factor, or not my factors, my zeros. But I can use those zeros to create linear factors by getting them each set equal to 0. So I have x minus 4. I just subtracted 4 from both sides. I have this x, oh, this should be a -1/2, I apologize, x plus 1/2. X minus root 5, x plus root 5. I want to be careful. This is not an equation. This is an expression. I'm setting it equal to 0 because I found them finding zeros. It's just how I am. But let's say I said my coefficient has to be 2. Well, I got to clean that up. If I take x plus 1/2 equals 0, can't I multiply it all by 2? So I have my factors, and these are linear factors, right? All of these x's have a power of 1 upon them. And that's how I factor that fourth degree polynomial into linear factors. Okay. Factor. We're going to factor this polynomial into 4 linear factors. Okay. I got to confirm that we have 4 linears. We'll go through that in a moment. You must give an exact answer, meaning you can't use a decimal approximation. If you get stuck, you may use your calculator. However, you may not use a calculator on the test for this a problem like this. First thing I notice, I have a GCF. And again, I suspect my direction might be wrong with 4 linear, so we're just going to get this down to as many linear factors as we can. And then I'll change my direction if I need to. Why do I need to factor out that x? Because if I'm going to do finding possible zeros, I need that constant term. X is a GCF. And don't drop them off at the end. Even though what I'm highlighting in green is what I'm going to be doing my division on. Okay? So I'm going to go ahead and recommend you pause the video to work through this problem. You are only doing your division or finding possible zeros for the green. So if, aside from a 0 being 0 because of this x being out here, I just confirmed that 1 is also a 0. But now this is only a 4th degree, so I need to keep doing my division to reduce this down. So go ahead and pause this video and try to find another 0. So I learned that 1 is another 0. Now, right here, the first time I divided, I was at a 4th degree. When I divided again, I'm now at a 3rd degree. So I really want to get it to a quadratic. So go ahead and try to get this down to a quadratic. Wow, look at the multiplicity. At this point in time, we have 1 that is 0 with multiplicity of 3. But I'm down to a quadratic. And that factors to that. So now 1 is a multiplicity of 5. So I should have said 6, I don't know what I'm writing there, 6 linear factors. So our linear factors, we can't forget the x. We have x minus 1 to 1, 2, 3, 4, 5 to the 5th power, which essentially is this. I'm going to skip this just for fun one. It's coming up in the next unit when we start incorporating, we go beyond the rational zeros, the irrational zeros. We add in complex, which are rational, irrational, and imaginary. I appreciate your time. Please reach out to your instructor if you have any questions. Have a good day.